Hello viewers, today we are going to see about acceleration. Okay, first we will see about instantaneous acceleration and average acceleration, the formula. Instantaneous acceleration is given by A, which is equal to limit del t tends to 0, del v by del t, which is equal to dv by dt. Then average acceleration A bar is equal to v2 minus v1, final velocity minus initial velocity divided by final time minus initial time, t2 minus t1, which is equal to del v by del t. The difference between average velocity and instantaneous velocity is, in instantaneous velocity you can find out the acceleration at each and every point, whereas for average velocity you don't know what's happening between the initial point and the final point. It gives only the average acceleration. First we will go into average acceleration and then we will discuss about instantaneous acceleration. Assume this is the nature of velocity of a particular vehicle with respect to time. So it goes, now if you see, it goes something like this curve, then a constant, and then it decreases like this. X-axis is time and y-axis is velocity, meters per second. Okay. Now we will take some time intervals and see what's happening with the average velocity. First I will take 0 second to 10 second. So 0 second to 10 second. First case 0 second to 10 second, then second case 10 second to 18, and third case 18 second to 20 second. First we will see 0 second to 10 second. 0 to 10 second. At 10 second if you see, the velocity is 24 meters per second. At 0 second it is 0. So V2 minus V1. Now V2 is what? 24 minus 0, initial 0 divided by T2. At this point time is 10. And the initial point it is 0. So 24 by 10 is 2.4 meters per second square. This is called positive acceleration because the value is positive, 2.4 meters per second square. Next we deal with 10 to 18. There is no change in velocity. Carefully if you see, there is no change in velocity. Velocity is same. Only if there is a rate of change of velocity we can say acceleration is there. But in this case between 10 and 18 you don't see any change in velocity, therefore straight away you can tell the acceleration is 0. But we will apply it in the formula. So A bar is equal to final value at 18 it is 24 and at 10 also it is 24. So 24 minus 24, the final time is 18 and the initial time is 10. So 18 minus 10 is 8. 0 by 8 is 0 meters per second square. So that means this does not have any acceleration. That means the vehicle is moving with constant velocity of 24 meters per second between 10 second and 18 second. Now we will come for the case 3 between 18 and 20. So at 18 if you see it is 24 and 20 if you see it is 0. Therefore between 18 second to 20 second acceleration is 0 minus 24. The final value here, this is final value and this is initial value, because from here it is going here. So this is final value, at this it is 0 and the initial value here is 24. So 0 minus 24 divided by the time difference is 20 minus 18, which is 2. So minus 24 divided by 2, which will give you minus 12 meters per second square. That means now you can see negative. That minus sign indicates it is having negative acceleration or retardation. So this is negative acceleration. So in this example we have seen all the three cases: positive acceleration, negative acceleration and no acceleration. That is this portion, it is moving at constant velocity. Okay, this is all about average acceleration. Now we will see one example based on instantaneous acceleration. So instantaneous acceleration is limit del t tends to 0 del v by del t, which is equal to dv by dt. So I will go by differentiation method. to solve one equation to find out acceleration. So the velocity is given. This is another example problem 2. So example problem 2. Now v is equal to, now I am interested in finding out instantaneous acceleration. So velocity is given as 3t cube plus 2t square plus 4. So acceleration is dv by dt. Now if you differentiate this velocity, 3 into 3, 9, t, this will minus 1. 3 minus 1 is 2. That is 9t square. That is, we are making use of this formula. d by dx of x power n is n x power n minus 1. Next is 2t square. So 2 into 2 is 4. T power 2 minus 1 is 1. Therefore 1. If you differentiate a constant, it is 0. So 0. Okay. Now I am interested in to find out the acceleration at t equal to 1 second. You can, if you are interested in 2 seconds, 3 seconds, any point of time, you can always find the acceleration. So I am interested in finding out the acceleration at t equal to 1 second. That gives the instantaneous value of acceleration. So acceleration is at t equal to 1 second is, you substitute the t value as 1 in this equation. So 1 squared is 1, here also 1. So 9 plus 4 is 13 meters per second square. That is 13 meter s power minus 2. Okay. So that's the instantaneous value of acceleration value at t equal to 1 second. So there is a difference between instantaneous acceleration and average acceleration. Hope you have understood by these examples and by these graphs, you have understood this topic. Thanks for watching this video. Nandri.